Alright folks, welcome to my channel. Let's continue our statistic and probability today. So we will take a look at Bernoulli and binomial distributions. The Bernoulli distributions are also called the binomial distribution. So let's say that tossing a coin, the probability of the event that lands head is given by the 0 to 1, and let y denote this event, and let y equal 0 denote the event that the coin lands tails. Thus, we are assuming that probability of y equal 1 equal theta, and probability of y equals 0 equal 1 minus theta. And this is called Bernoulli distribution. So this is the Bernoulli distribution you can describe, and it is univariate distribution. You graph it as follows, and based on the theta, which is theta is like a parameter, so based on the parameter value, the distribution shape will change. Yeah, so the symbol this is equivalent to the sample form. So it is distributed as Bernoulli distribution. The y is distributed as Bernoulli distribution with the parameter theta, and this parameter change between 0 to 1, and in the case 0.25 it goes left shape. When the theta is 0.9 it goes the right shape. Probability mass function is described as follows as well. And the Bernoulli distribution is a special case of the binomial distribution. That you can get what is called the binomial coefficient. So when binomial distribution n equal 1, it will reduce to the Bernoulli distribution. So you can think of it as the type of the parameters, and one of the parameter n is fixed. N is the sort of the number of events, so the coin n times it is reduced to 1. Now look at the sigmoid function. So the sigmoid function is a distribution where you take input value and reduce to the conditional probability distribution. The way to describe probability 1 is given by the x and theta. So the y equal function x and parameter theta, and that is what sigmoid function. So the sigmoid is specified as this parameter. And you sometimes also call it as logistic function. So the concept apply when you use logistic distribution, logistic regression, for example. It is useful to reduce certain value between 0 to 1 probability space. So you basically apply the specific type of value and reduce this between those certain range that you get more squeezed information compared to you use sort of like a linear type of loss function, so to say. That comes later section. And binary logistic function, that is the conditional Bernoulli model for this distribution logistic regression, and that is the way transform x plus b. This is intercept. So the logistic regression is described this way, and it is, like I say, it is also called the decision boundary, simply because the function can take a specific value and produce their certain range of the probability, so to say. So you can reduce the information to, let's say, the binary classification. Like the good example, if it's dog, if it's cat, that is basically to say 1 or 2, or maybe 0 or 1. You can use this type of distribution to compress the higher dimensional data. And categorical distribution, so categorical distribution can be so the idea of one hot vector or the unit vectors, that is the representing the certain value with the 0, 1. So it's like a computer where you have this 0, 1 sequence to represent the program. And here categorical distribution is used for, let's say, the encoding. What is encoding? Encoding can be used to represent the either binary category or the multi category situation. Let's say there's animal category, but animal can be dog, cat, but then also it can be zebra, it can be gorilla. Then you cannot just describe them, all right, 0, 1, because there's more. So how do you represent those animal classification? Then you can use it one hot vector, or simply categorical distribution to categorize item with the class, and it is like a turning on switch. So when it's category, it turns into 1, otherwise it's 0. So you can represent as the sequence of the number. If it's 3 categories, then of course you can represent with the 3 numbers. As simple as that. And if it's more than 2 categories, then it will expand to multinomial distribution. Alright, so the softmax function, this is also very important function. You might already get familiar. It's the categorical distribution, and take function x theta parameters, y is sort of the output, but then you reduce it conditioned 1 and function. So this means the softmax function will take the number. So softmax function takes whatever the input value and generates this small digit And if you combine all the x, so x can be certain values, so you can think of it like the height of the people. And the height of the people, there is like 100 people, then there is 100 of the x. And those are summed up eventually with the softmax function, and which will equivalent to 1, because softmax function reduce those values. So cumulative distribution function is the specific function. I mean, the Gaussian distribution here also means that it has parameter mu and sigma square. That to say, it has the mean and it's a variant. So it can describe it as two specific property that create the function. So the distribution is very specific. Sometimes it is also called bell-shaped distribution. The cumulative distribution function itself is more gradual, and the later point that will also come to the concept that the probability distribution function, we probably already discussed it, but that's the shape. So this is probability distribution function, and this is cumulative distribution function. And yeah, so the probability density function, that's the other one that we just saw it. And the relationship between those two is very close, in a sense that you can take some mathematical calculation and generate one and the other. So those are very tightly coupled.